बिस्मिल्लाहिर्रहमानिर्रहीम। आज का हमारा लेक्चर चैप्टर नंबर 4 बुक 1 लिक्विड्स एंड सॉलिड्स। इस चैप्टर में जो कंटेंट्स हैं उन जिनको हम डिस्कस करेंगे वो हैं इंटरमॉलिक्यूलर फोर्सेस, एवेपोरेशन, वेपर प्रेशर, मैनोमेट्रिक मेथड, बॉइलिंग पॉइंट, लिक्विड क्रिस्टल्स, क्रिस्टलाइन सॉलिड्स, यूनिट सेल, crystals and their classification, and last one the classification of solids like ionic solid, covalent solid, molecular solids and metallic solids। इस चैप्टर को हमने तीन हिस्सों में डिवाइड किया है। फर्स्ट पार्ट में हम डिस्कस करेंगे इंट्रोडक्शन अप टू वेपर प्रेशर। इंटरमोलेकुलर फोर्सेस फोर टाइप्स की हैं, जिनमें डाइपोल डाइपोल फोर्स, आयन डाइपोल फोर्स, डाइपोल इंड्यूस्ड डाइपोल फोर्स एंड लंडन डिस्पर्जन फोर्सेस। एंड हाइड्रोजन बॉन्ड it include in intermolecular forces and intramolecular forces also. Dipole dipole force, attractive force between positive pole of one dipole and negative pole of other dipole, is called dipole dipole forces. While ion dipole forces, attractive forces present between positive pole of dissolved salt and negative part of water molecule or other molecule is called ion dipole forces. What is dipole induced dipole forces? Force present between positive pole of polar molecule and temporary negative pole of non-polar molecule is called dipole induced dipole forces. They are also called Debye forces. London dispersion forces or instantaneous dipole induced dipole forces. Instantaneous forces present between temporary poles of non-polar molecules is called London dispersion forces. And you know that hydrogen bonding. What is hydrogen bond? The electrostatic force of attraction between partial positive pole of hydrogen and with highly electronegative element like fluorine, oxygen and nitrogen is called hydrogen bond. Dipole dipole force example is that, for example, HCl in a solution. Ion dipole forces, for example, salt NaCl dissolved in water. Dipole induced dipole forces, for example, sulfur dioxide and helium. London dispersion forces, for example, in noble gases like helium, neon, argon, krypton, xenon, radon. Hydrogen bond exists between water, acetic acid, alcohol, etc. If we compare the strength of these forces, dipole dipole force, more electronegative difference, greater will be the strength of force. More electron difference in salt, greater will be the strength of ion dipole force. More collision among the molecules, greater will be the strength of dipole induced dipole force. More collisions among the molecules, greater will be the London dispersion force and depend upon the polarizability size. Also, hydrogen bond, electronegative difference between hydrogen and more other atoms will enhance the strength of hydrogen bond. Existence between polar molecules, dipole dipole forces between polar molecules, ion dipole force between polar molecules, dipole induced dipole force between polar and non-polar molecules, London dispersion force, all type of polar and non-polar molecules, and hydrogen bond between polar molecules. Effect of atomic size. In dipole dipole force, atomic size has no effect, while in ion dipole force, large size of atom of salt ionize easily. While dipole-induced dipole force size has no effect on dipole-induced dipole force, larger the size of atom, greater will be the London dispersion force, because when size increases, polarizability increases, strength of London force also increases. While size of atom has no effect on hydrogen bond. Effect of temperature at constant pressure. Dipole-dipole interaction inversely proportional to temperature. Ion dipole force directly proportional to temperature. Dipole-induced dipole force directly proportional to temperature. London dispersion force is directly proportional to temperature. Hydrogen bond is inversely proportional to temperature. Properties. Thermodynamic properties of covalent hydrides. Greater the electronic difference, greater will be the hydrogen bond. Greater will be the strength of hydrogen bond. Compound with such conditions have higher boiling point than those molecules which does not have such property. Greater the number of hydrogen bond among the molecules, greater will be the boiling point. Like in HF and water, more electron difference in between H and electronegative than H and O, but water has more boiling point than HF. It is due to greater number of hydrogen bond in water. Water has 2 hydrogen bond per molecule while HF has 1 hydrogen bond per molecule. That's why the greater number of bonds in water, it means that it has greater boiling point than that of HF. Solubility. Lower alcohol and carboxylic acid are more soluble in water due to hydrogen bonding. Cleaning action. Hydrogen bond increases the cleansing action of soaps and detergents. Application in biological compounds. Gene is hereditary material which control the character of organism. Genes are present on chromosomes, thread-like structure. Chromosomes are made up of two deoxyribonucleic acid and proteins. DNA is a double helix structure. Both helix are close together through the hydrogen bond of nitrogen bases of both helix. Hydrogen bond in plants and dyes. The adhesive property of plants and other dyes like glue honey is due to hydrogen bond. Clothing. Hydrogen bonding involved in thread making materials. food material. Carbohydrate, glucose, sucrose, lactose, fructose contain hydrogen bond. Structure of ice. In ice, air spaces are present due to the structure of water molecule. Due to spaces, ice float on water. Specific density of water of 4 degrees Celsius is highest. Water has maximum density at 4 degrees Celsius. Definition. Evaporation. What is evaporation? Spontaneous change of liquid into vapors at a given temperature is called evaporation. Process in which liquid molecule changing into gaseous phase is called evaporation at all temperature. Evaporation causes cooling. Evaporation is a cooling process. Equilibrium state. The state at which rate of evaporation become equal to rate of condensation, then equilibrium will be developed, and that is a dynamic equilibrium. Condensation. Change of gas molecule into liquid is called condensation. Effect of area. Greater the area, greater will be the rate of evaporation. Effect of nature of liquid. Polar liquid show lesser evaporation due to strong intermolecular forces. Effect of intermolecular forces. Greater the strength of intermolecular forces, lesser will be the rate of evaporation. Temperature. Greater the temperature, greater will be the rate of evaporation, because temperature is directly proportional to rate of evaporation. Vapor pressure. The pressure of the vapors on the surface of a liquid at a given temperature in a closed container is called vapor pressure. Pressure exerted by vapors on the surface of liquid when they are in equilibrium with the liquid in a closed container is called vapor pressure. Factors. Effect of temperature. Greater the temperature, greater will be the vapor pressure. Number of molecules. Greater the number of molecules, greater will be the pressure. Nature of liquid. Polar liquid have less vapor pressure due to strong intermolecular forces. Measurement. Vapor pressure of unknown liquid can be measured by manometric method. Manometric method. Thermostat is system whose temperature can control by will. Vacuum is created to evacuate the air from apparatus by vacuum pump. Liquid is frozen and then melted so that air entrapped in liquid may be released. That is manometric method. First of all, liquid take in a flask. It freezes. First of all, it freezes with the help of freezing mixture, and the air bubble removed with the help of vacuum. And after that, it is heated that the air entrapped in liquid molecules also release. This process repeat again and again to purify the liquid. When liquid is purified, it is heated that vapors are formed. These vapors are moved toward manometric where they exert pressure. There is a difference between two limbs, and this difference is called delta H. Which of the following has strongest intermolecular forces? Alpha option hydrogen, iodine, chlorine, methane. So the best answer is iodine. Strongest intermolecular forces between iodine, because hydrogen is a gas, chlorine is a gas, methane is a gas, while iodine is a solid. It has large polarizability, it has strong London dispersion forces. That's why the right answer is Charlie. Vapor pressure of water at 100 Celsius is, at 100 Celsius the vapor pressure of water is 760 millimeter of mercury, that is 760 torr. So the right answer is beta. Which one of the following does not show hydrogen bonding? Water show hydrogen bonding between O and H. Phenol show hydrogen bonding between O and H. Ethyl alcohols show hydrogen bonding between O and H atom. While diethyl ether do not show hydrogen bonding, it has a dipole-dipole force. So the right answer is delta. Diethyl ether, it has a dipole-dipole force. Actually, the vapor pressure on the surface of liquid in the flask is equal to, vapor pressure is measured in manometric method. The equation which is used in manometric method is that P is equal to PA plus delta H. That is atmospheric pressure 1 atm, and delta H is the difference between mercury level. Steam causes more severe burn than the boiling water because it possesses the latent heat of vaporization. That our right answer is beta. Formation of vapors from the surface of liquid is called evaporation, and it is a cooling process. So the right answer is beta. For further MCQs, see practice book with detailed explanation. Thank you.